Picture a fishing boat, not on the water, but tilted on its side in the open sand, its steel hull scoured orange by rust. Walk in any direction and you will not find a coastline. It is over 100 kilometers away, past a horizon of cracked white salt. A vessel like this once hauled catches by the ton. The question hiding under this sand is how one of the largest bodies of water on Earth vanishes within a single human lifetime, and it happened without the rain ever failing. To see what this place was, you have to look at the map from 1960. This was the Aral Sea, the fourth largest lake on the planet. It stretched across what is now Kazakhstan and Uzbekistan, kept full by two massive rivers pouring down from the mountains of Central Asia, the Amu Darya and the Syr Darya. For thousands of years, these rivers delivered the snowmelt across the desert. That constant inflow perfectly balanced the massive evaporation caused by the hot Central Asian sun, keeping the sea and its delta wetlands alive. It was an exceptionally stable geographic arrangement. The sea did not vanish because of a sudden shift in weather. In a matter of decades, people took it apart. In the 1960s, Soviet central planners looked at these dry plains and saw agricultural potential. They mandated the mass production of cotton, a crop they valued as white gold, to clothe an empire and drive exports. The immediate problem was that cotton is an intensely thirsty plant, and the desert surrounding the Aral Basin is among the driest regions in Asia. The planners made a deliberate decision to solve that geographic mismatch. They would take the water from the Amu Darya and the Syr Darya and divert it away from the sea, pouring it directly onto newly designated farm fields. To move that water, they initiated an enormous engineering campaign. They carved thousands of kilometers of trenches across the sand. One of these, the Aralkum Canal, ran for hundreds of kilometers across Turkmenistan, drawing off a staggering share of the Amu Darya. The sea itself was purposefully traded away. The diversion was a calculated transaction, exchanging a vast inland ecosystem for agricultural wealth. Look at how this water was moved. These were not efficient sealed conduits. Many were simply unlined trenches dug straight into the desert. Enormous volumes of water soaked directly into the sand or evaporated into the air long before reaching a single cotton plant. To keep the cotton growing, engineers continuously pulled more from the source. By 1961, the Syr Darya delivered essentially no water to the sea. Its entire flow had been captured upstream, severing the sea's major lifeline. With the rivers blocked, the sun continued to evaporate the lake, and the water fled. In 1950, the town of Muynak sat on an island in the river delta. By 1962, the shrinking water turned it into a peninsula. By 1970, it was stranded 10 kilometers inland. The shoreline pulled back so quickly that entire fleets of fishing ships were left stranded where they were moored. A harbor town watched its sea simply walk away. Without the river inflow to pay the debt of evaporation, the Aral was hydrologically bankrupt. An inland ocean that had existed for millennia collapsed in a matter of decades. As the volume of water plummeted, the salt already dissolved inside the lake concentrated. The sea grew so salty that native fish died out entirely, erasing the livelihoods of the roughly 60,000 people who worked the fishery. When the water retreated, it exposed tens of thousands of square kilometers of bare seabed. This created the world's youngest desert, an area now known as the Aralkum. This new landform was composed of fine, light sediment. Mixed into that dust were decades of salt, along with the agricultural pesticides and fertilizers that had steadily washed off the upstream cotton fields. The wind sweeping across this flat expanse lifted that fine, poisoned sediment into the atmosphere, generating massive, toxic dust storms. Those aerosols traveled staggering distances. Airborne salt from the dried Aral seabed caused alarming rates of respiratory illness in local communities, and eventually drifted out to land on the peaks of the Himalayas, the Pacific Ocean, and the shores of the Arctic. The choice to grow cotton replaced a stable inland sea with a source of globally circulating dust, while dismantling the body of water that once regulated the desert's extreme seasons. By 2014, the eastern lobe of the South Aral Sea had disappeared entirely. It was dry for the first time in perhaps 600 years, signaling the end of the southern ecosystem. But to the north, in Kazakhstan, a different approach emerged. In 2005, with international backing, they built the Kok-Aral Dam. The logic of the structure was cold and practical. They accepted that the hyper-salty southern basin was lost. Instead of letting the remaining flow from the Syr Darya vanish into the doomed south, they trapped it entirely inside the smaller northern basin. It was geographical triage. By deliberately shrinking the boundaries of the sea, they concentrated the remaining water into a space it could actually fill. Engineers estimated the North Aral might take 5 to 10 years to show meaningful recovery. The water rose and began reaching abandoned ports in a matter of months. As fresh river water diluted the toxic salt, native fish populations rebounded. Slowly, the local fishing industry began to resurrect itself from the dust. Today, the vibrant, sudden recovery of the north stands in sharp contrast to the permanent, dry desolation of the southern desert. The Aral stands as a warning. Decisions made hundreds of kilometers upstream can erase a regional ecosystem and alter its climate in less than 50 years. The Aral is a running total of how we manage water, a geography that can be lost, and sometimes, through calculated triage, partially reclaimed.